Alright, look at this question. They said the diagram above shows the VT graph. Let me take this a little bit backwards. Yes. Shows the VT graph of a truck which accelerates uniformly from rest at 2 meters per second squared for 10 seconds, maintains a steady velocity for 30 seconds, and is then brought to rest in 5 seconds under a uniform retardation. The total distance traveled is. Now, normally, this question is from the equation of linear motion. Alright? It's from the equations of linear motion. Now, since this question is from equations of linear motion, it is normal for us to note some certain things. It's a velocity time graph where the y-axis is the velocity and the x-axis is the time. So it said the diagram above shows the VT graph of a truck which accelerates uniformly from rest, means the truck started from here, alright, at 2 meters per second squared for 10 seconds. So it moved from here to this point for 10 seconds, alright, and then I'm putting 10 here so that you can see. Then this was the acceleration, 2ms minus 2, right? But we don't know what the velocity states, so we can find the velocity by doing acceleration equals to velocity over time. If we can get the velocity there. Then it says maintain a steady velocity for 30 seconds. So when it got to this velocity, it maintained it for 30 seconds. If you do that, 30 plus 10 will make this place to be what? 40. Alright? 40. So then I say it's brought to rest in 5 seconds. If you add 5 seconds for the resting side of the graph, it will be 45. You understand? So the question they are asking us now is the total distance traveled. Now when you have a VT graph like this that is so straightforward, all you need to find is the total distance traveled. To find the total distance traveled, you need to calculate the area of the graph. You understand the point now? The area of the graph. And how do you find the area of this graph? Okay, since you have seen the question, I'm taking it out. The shape of the area of the graph is, you use the shape of the graph. That's how you use it. And what kind of shape do we have here? We have a trapezium, and the area of a trapezium is that's area is equals to half sum of parallel sides a plus b times h. Okay, now this is the same formula for total distance traveled, which is s is equals to average velocity, that's u plus v over 2 times t. As simple as that. That's the area of the graph. Okay, so what are the parallel sides? Though this is how it is, but this is not the formula I'm going to use. I'm just going to use the area of the graph. The parallel sides A is from here to here. Okay, because these are the two parallel sides of this trapezium. So my A is equal to 30. If you subtract, my B is equal to, total length is 45. Then what's my H? My H is my height. And my height of this graph is the velocity here. For me to get the velocity, I have to know that acceleration is equals to velocity over time. So velocity is equals to acceleration times time. So velocity is equals to 2 times 10. So velocity is 20 meters per second. If you put that as here, 20, solve your area of the graph, you get 1 over 2 open bracket 30 plus 45, close your bracket, times 20, which is your height. Your height is your velocity from the vertical side of the graph. If you solve this, you'll be having something like this. Area to be equals to 1 over 2, 30 plus 45 will give you 75 times 20. If this goes here, your area is equal to 750 meters. 750 meters is total distance traveled by a graph. I hope this is understood and it's easy for you. Enjoy.